Okay. Tá, vamos lá.
For the ready button. Okay, let's save. Back here in the editor, let's drag the reference, alright. And now the goal here is to pretty much use exactly the same logic that we made for the kitchen manager. Over here on the main game manager script, we had the ready logic, so the game would only start when all of the players were ready. So the logic is exactly the same, so let's actually
Okay.
copy the exact code. So let's copy first of all the playwright dictionary, except we don't want to run that logic directly over here on the UI script, so let's make a proper script. Let's create a brand new game object for the character select ready.
Tá.
And let's make a script with the exact same name, so the character select ready. Let's reset the transform and add the character select ready. Okay. Now this one, let's actually paste that code. So first of all, let's copy over here the playwright dictionary, and over here let's paste it. Okay, we have the dictionary. Then need to initialize it on awake. So on awake, the playwright dictionary. Let's make a brand new one. Then let's see
Calma.
what other initialize it on awake. So on awake, the playwright dictionary. Let's make a brand new one. Then let's see what other logic we're using with this one. And it's down here, we have an RPC in order to set it as ready. So let's just copy this entire function. And over here, and it's down here, we have an RPC in order to set it as ready. So let's just copy this entire function. And over here, let's paste it. And when you do, make sure you add using Unity.NET code up here. Visual Studio should do it by default, but make sure you do it. Okay, so this is really going to do the exact same thing. So go through the playwright dictionary and see if they are all ready. And if so, then it's over here. Instead of setting the state, over here, we're just going to load the final scene. So going to the loader, and again, remember to use the load network function. And we're going to load the game scene. Okay, so that's really it. Super simple. Then for calling the server RPC, let's expose a function, set play ready. And over here, we call the set play ready with the server RPC. So we just need to call this function from that button in the UI. So let's go up here, make a public static character select ready in order to make our static instance. They get any private set. And over here on the wake, set instance equals this. Okay, great. So now any private set.
Tá. Que isso, meu Deus? Static.
And over here on the wake, set instance equals this. Okay, great. So now back here on the testing character select UI, let's make a simple awake. Let's go into the ready button, the onclick, let's add a listener. And on the listener, let's just go into the character select ready, the instance, and let's set the player as ready. Okay, so that's it. This should be working. Let's just do one more thing. Let's go into the game scene. So let's first of all save this scene, go inside the game scene, and over here on this one, on the canvas, we no longer need the testing netcode UI. So let's just disable this one like this. And actually, just one final thing that I forgot. Over here, in order for the server RPC to actually work, we need to make sure this one is not a mono behavior, but rather a network behavior. Then back in the editor, let's go into the character select scene, select the object, and yep, let's add network object. That way should work. Okay.
Ah, é que vai dar errado, né? Onde é que eu tô? Peraí, na cena... Lobby. Character select. Yes, ok. Agora se eu dou um Ctrl B. Ok, aí que eu dou play de cá. Create. Ai. Ai. Chama. Ok, só não spawnou o boneco ainda.
Great, so we're ready to test. Let's go back into the lobby scene. Again, this is important. We always need to start from the lobby because this is where the network manager is created. So with this, let's make a build and test. Okay, so here we are. So up here, let's create a brand new game. And yep, on the character select scene. Now on this one down here, let's join the game. And yep, there you go, it does work. So both of them are on the character select scene. Now on this one up here, I'm going to click on ready. And there you go, this one is ready, but it did not load the game scene. It is still waiting for this one down here to be ready. And as soon as I set ready on this one, it is going to tell the server that it's ready. And yep, there you go, the server automatically loads the final game scene, and this one loads with it. All right, awesome. So everything is working great. Now over here, we are waiting for players, and there you go, it works. However, obviously, you might be noticing one issue right now. Since we removed the automatic spawn player prefab, we have nothing over here. So we need to manually spawn the player. Let's do that. Let's do that over here on the kitchen game manager. This script only exists on the game scene. And for spawning, we only want to spawn when all of the players have loaded. So for that, let's go down over here onto the on-network spawn. Let's go in the network manager. And if we go inside the singleton and then inside the scene manager, over here we have a function on load event complete. This one is
Calma.
triggered when all of the clients have loaded the final scene. Again, it's important, it's this one, not this one. This one up here is triggered on a per client basis, whereas this one down here is when all of the clients have loaded. So let's go with this one. Let's listen to this one. And over here, it's pretty simple. We just want to spawn all of the players. So let's cycle through all of the connected clients. So ulong for the client ID. In the network manager singleton, the connected client list. Okay, we have all the connected clients. Then we need to spawn the player prefab, so we need a reference. Let's add it up here. So a serialized field, private transform for the player prefab. So we have this. Then the editor, let's go inside the game scene and let's go into the kitchen game manager and let's make sure to drag the player prefab. There it is. Also, one important thing, since we are spawning the player, let's go into the lobby scene. Let's make sure to save. And on this one, on the network manager, in order to spawn the player prefab dynamically, we need to make sure we add it up here. Since we removed it from the player prefab up here.
Ah, tá. Então, pera aqui. Então, aqui eu tenho que colocar o player.
We need to add it onto the network prefabs. So let's add a brand new one and drag the player prefab. Okay, great. Back in the code here, we have the player prefab. So down here, let's just call instantiate the player prefab. So this is going to return our player transform. So we have this, then on this one, let's do a get component to grab the network object. And on the network object, we can call the function spawn as player object. So not the spawn, but the spawn as player object. This one. One takes a client ID, so let's pass in this client ID. And then for destroy with scene, we do want the player prefab to behave as a regular game object, so we do want it to destroy with scene, so let's go with true. Alright, so that's it. This will spawn the player prefabs, and after that, the rest of the game should work perfectly. Okay, so let's test. And again, as always, in order to test, make sure you test from the lobby scene. Okay, so on this one up here, let's create. The brand new game. All right, here we are. Then down here, let's join. Okay, it works. Now let's set as ready. Still waiting for this one. This one goes as ready. And yep, both have loaded the final game scene. Now as I start playing, and there you go, each of them now has their own player controller. And now, yep, all of the rest of the game, all of it is perfectly synchronized. All right, awesome. Next, let's handle the connection accept logic. So over here on the kitchen game multiplayer, we modify this callback in order to always approve. Now we only want to accept while we are on the character select scene. So let us test if the current scene is the character select scene. So let's do a simple if. Let's go into the scene manager. Let's get the active scene and let's get the scene name. Then we compare. Let's compare with the loader.scene and check if we are in the character select scene. Now we need to compare string with string, so let's use the toString. Okay, so we compare if we are on the character select scene, and basically if we are not on the character select scene, then let's approve as false, so cannot connect. Then let's return a reason, so on the reason, let's just say the game has already started. Okay, so that one we don't approve, and then let's return to stop the rest of the execution. The next validation is checking the max number of players. We only want 4 players maximum. So over here we can do an if. Let's go into the network manager, the singleton, get the connected client IDs, and we check the count, and we compare it against something. So for defining the maximum, let's actually go up here and make it a constant. So a private const int for the max player amount. And let's say we want a maximum of just 4 players. Okay with this. And now down here we can compare. If we already have way too many, then once again, same thing, let's not approve. And let's say game is full. Okay, and if it's neither of these, then we do accept it. Okay, so that's the logic. Now let's add a visual. The connection starts here on the lobby scene, so let's add the visual here. Let's go inside the canvas and create an empty game object. Let's call this the connection response message UI. Let's make it stretch to occupy everything and put 0, 0 on everything, okay? Then inside, let's create a new UI image, call this the background. And again, let's make it stretch to occupy everything. And let's put this one on black with a little bit less alpha. Okay, great. Then let's also add a text, so a new UI text. Call this the message text. And here we're going to say some message. So let's put it the usual setup, so width and height of 0. Let's disable wrapping, put it down center, down the middle.
Tá, diminui isso aqui, isso aqui. Eu acho esquisito essa maneira aqui de pôr o texto, né? Mas.
In bold and lift it up by a little bit. Okay. Then let's also have a button. So a new UI button, call this the close button. And inside, let's say close. Let's put the button text in bold, put it in white, and for the parent, for this one, put it in a dark gray. And just like this, we have a simple, nice button on X of 0. Okay, great. We have both elements. On this window, we're going to show the disconnect reason message. Now let's duplicate this one for another window, just saying connecting. So let's duplicate this window, call it connecting UI. And on this one, get rid of the close button. We just have a message. And for the message, let's just say connecting. Okay, just like this. Now here, obviously, you could merge both these windows into just one, but let's keep them separate to keep things a bit more clean. So we have our UI setup. Now we basically just need to know when the player tries to connect and when that connection fails. So over here on the kitchen game multiplayer, let's make a bunch of events. So let's make a public event handler, and let's call it on trying to join game. Another one on fail to join game. Okay, then let's go down here, and the first one is
Tá, public event handler trying to
on fail to join game. Okay, then let's go down here, and the first one is when trying to connect. For that one, let's fire over here before we call the start. Start client. So let's invoke with the usual this event args.empty. Okay. And then for the disconnect failure, for that, let's also go up here where before we call the start client, let's listen to the disconnect callback. So the network manager, the singleton on disconnect callback. So let's listen to this one. Let's give it a proper name. So the network manager. Okay, so we have a disconnect callback, and here we've got the client ID. And on this one, let's fire off the event. So on fail to join game. So let's invoke with this an event args.empty. Okay, we have both our events. Now let's make these scripts for our windows. So let's make first over here the connecting UI. So let's create a brand new UI script. Over here, let's attach it and open. Okay, now let's make the usual show and hide functions. So private void show, and then we have a private void hide. And same thing as always, so set active as false or as true. Okay, now let's do a private void start. And on start, we're going to list. listen to some events, and then we hide it. So for the events, this one, let's listen when we try to connect. So the kitchen game multiplayer, the instance, on we are trying to join the game. So when this one happens, so let's rename this kitchen game multiplayer. So when this event happens, let's show this window, and then let's also hide it when that one does fail. So on fail to join game, let's add this listener. So when it fails to connect, let's hide. Okay, great. Now let's make the other script. So the connection response message UI, let's build this one. Over here, let's attach the script and let's open. Okay, so here we're going to have pretty much exactly the same thing. So let's have the usual private void show and hide. Then let's add references to the text and the button. So let's add a serialized field. And first for the text, this one is Text Mesh Pro UGUI for the message text. And then we have another one. This one is a button, and this is going to be the close button. Okay, let's save this. And here in the editor, let's drag the references, so the message text and the button. All right. Then let's add our listener. So on private void awake, let's go into the close button. On the onClick, let's add a listener, and this one is going to be just the hide function, so that is just going to hide the window. Then let's do our private void start, and on start, let's listen. So kitchen game multiplayer. The instance, when it fails to join a game, let's listen to this one. So on start we listen, and then we hide by default, and when it does fail to join the game, let's show this, and then let's set the message text. And for the disconnect text, we can grab it from the network manager, the singleton, and we grab the disconnect reason.
Ó. Desculpa, é verdade, né, que eu não tenho argumento.
So yeah, that's it. Just like this, both our scripts should be working. However, here let me point out one very, very important thing. One question that I got a lot in the single player course is with regards to unsubscribing from events. You might have noticed that we pretty much never unsubscribe to events. That is because you only need to unsub if the objects have a different lifetime. If both the publisher and subscriber have the exact same lifetime, then you don't need to manually unsub. However, over here, these objects do have a different lifetime. These UI windows, these only exist on the lobby scene. As soon as we change scenes, they will be destroyed. But the kitchen game multiplayer, this one will live through all the scenes. So we need to make sure to unsub because this object is going to have a different lifetime than the kitchen game multiplayer. And how we unsub is very simple. Let's just make a private void on destroy. So this one is a mono behavior function, which is called when this object is destroyed. So on this one, we really just unsub. So just go into that one and do minus equals. So we do it over here, and on the connecting UI, same thing, private void on destroy. Let's unsub to both of these. So just do minus equals. Okay, great. So now we can test. All right, so here I've got 1, 2, 3, 4, 5 clients. So on this one up here, let's create a game, and there you go, it did work. Then on this one, let's join a game, and yep, it did work, connected, joined. On this one, join, yep, it worked. This one, join, yep, it worked. So now we have all 4 clients connected, so the game should be full.
Tá. Lobby. Ok. Aí vou dar play aqui. Três, 4, 5. Tá, vou dar create aqui. Ok.
Full now. So on the 5th one, if I try to join, and yep, there you go, the game is currently full. Okay, great, so that worked. Now let's actually quit one of these, so let's quit this one. So technically now we do have one slot available, so let's not connect right now. Instead, let's set this one as ready, this one is ready, and this one is ready. And yep, there you go, all of them are loading the final scene. So here we have our 3 players. Okay, great, but the game is now playing. So on this one, if we do try to join, and nope, the game has already started. All right, awesome. So all this logic is working perfectly. There's just one more possible failed connection scenario. That is simply if the connection just times out. If that happens, then the same event won't be fired. The only difference is the disconnect reason will not have any text. So we can just check if the disconnect reason is empty. So if we have no disconnect reason, then let's just set this one to just fail to connect. Okay. So that's the text. And also by default it will take a bit too long to timeout. So over here on the lobby scene on the network manager, if we scroll down, yep, over here on the NT transport, we do see a bunch of settings. So we have the connect timeout milliseconds, so meaning after 1000 milliseconds, so 1 second, it will wait 1 second until that connection times out, and then it will try to connect for a maximum of 60 times. This seems like a bit too much, so let's put it on just 10 tries. So if it fails after 10 tries, then after 10 seconds, it should say failed to connect. Okay, so let's test. So if it fails after 10 tries, then after 10 seconds, it should say failed to connect. Okay, so let's test. Here we are, and without creating a host, let's just try to join the game. And there you go, it is trying to connect, but there's no game, so it should fail. So after 10 tries, after 10 seconds, yep, there you go, we have our failed to connect message. Okay, great. So with that, we have almost our entire connection flow working. We start from the lobby, we can create the game, and we can join a game. We go into the character select scene, and then when all of the players are ready, when that happens, yep, the server loads the final game scene, and over here we can play as normal. So everything is working great. All that's left is the main menu. So if over here on the host, if I go back into the main menu, there you go, that one disconnects, so that's great, and I'm back on the main menu, so it looks great. But if we look in the hierarchy, yep, over there, look at that, the network manager and the kitchen game multiplayer, these objects are still active. So if we now went into the lobby scene, we would end up with duplicated objects and tons of problems. So basically we need to clean up these objects, and let's do it when we go back over here on the main menu. So let's go into the main menu scene, so let's open this. And over here let's make a simple script to clean this up. So let's create a new one, let's call it main menu cleanup. Let's make a script to run this. Let's attach the script and open it. And over here, a script to run this. Let's attach the script and open it. And over here, really all we need to do is just clean up both objects. So that's super simple. Let's make a private void awake. And on awake, let's just test if the network manager, the singleton, if this one exists. So if this one is not null. If so, then let's really just call destroy on the network manager singleton game object. And same thing for the other one. So the kitchen game multiplayer, if this instance is not null. If so, then let's destroy this instance.game object.
E
Okay, so that should work. With this, the objects should always be cleaned up whenever we go back into the main menu. Just one more thing, let's make sure this play button goes into the lobby scene and not the game scene. So on the canvas, let's open up the main menu UI.
Tá, peraí.
And over here, let's use the load, because over here we have no connection, so let's use the single player load. Instead of the game scene, let's just go into the lobby scene. And finally, we can go into the build settings, and now we can make sure that we start from the main menu scene. Okay, so let's test. Alright, so here in Let's Play, we're in the lobby and let's create a game. Then on this one, Let's Play, let's join a game. Set is ready, set is ready. And yep, both of them start playing. So yep, here we are both playing the same game. Now on this one, I'm tired of playing, so go back into the main menu. And if we look in the hierarchy, and if there go, no more objects, we have everything cleaned up. Now on this one, I can play again, I can create another game. Then on this one, go back to the main menu, and let's join again. Ready again, ready again. And yep, we are back in a brand new game instance. Alright, awesome. So here we handled our complete game connection flow. We start from the main menu in single player. Then on the lobby, we have a button to create the connection. In turn, that loads the character select scene where more players can join. Then on that scene, each player can set the ready to true. When all of the players are ready, the normal game scene loads, and then the game continues as normal. So yep, we have all of that working. Now all that's left is actually building out the lobby and the character select scene, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to build a nice character select scene where the player can select their player color. Okay, so here let's build a character select scene. This is actually one of the more common questions I've seen in my netcode video. Lots of games have this sort of thing, so let's build it. Let's go.
Tá, pera aqui. Não, tá frio. bora lá, bora lá, bora lá. Fiz o commit aqui.
Go to the character select scene, and first of all, let's just make some proper buttons. So inside our canvas, let's create an empty game object, call it the character select UI. Let's make it stretch to occupy everything. Okay, so now inside, let's add a UI button. Call this the main menu button. Let's anchor it on the top left corner, and let's move it a little bit like that. Okay, let's make it a little bit bigger. Let's make this in a dark gray, and inside for the text, let's say main menu. Let's put it in bold, in white, something like this. Okay, that's the button. Now let's duplicate this, make this the ready button. And for this one, let's anchor it on the top right, and let's put it over there, okay? Then inside...
Tá, pera aqui então, né? Botão. Ok. Toquei isso aqui, vai ser bem menu, tá? Ready.
I just say ready. Okay, now let's make a script to run this with the exact same name. So let's go into the UI folder, create a new C# script. Let's select the object, and let's add the script. So the character select UI. Okay, now here, first of all, let's grab the buttons. So as usual, a serialized field, private button for the main menu button, and another one for the ready button. Okay, here in the editor, let's drag our references. So that one. And the ready button, all right. And over here, let's add our click behavior. So let's make a private void awake. On awake, the main menu button. On click, let's add a listener. In order to go back into the main menu, first let's shut down the network manager, since on this scene we do have an active connection. So let's go the network manager, the singleton, and call shutdown.
Ok. Main menu. Opa. Ponto. On click. Ponto add listener.
And then afterwards we can use the load and not load. So that's the regular load, because right now we have shut down the network connection. And let's load back the main menu. Okay, great. And then for the other button, so the ready button, on click, add a listener. For this one, we just want to do the exact same thing we did on the testing script. So here the testing character select UI, we're running this, so let's run the exact same thing. So back in this script, just run that function. Okay, so that's it. Let's do a quick test. Before we do, let's just make sure to disable that one. All right. And again, and as always for testing, let's make sure.
Ai, aqui eu tenho que já tá lá no main menu. Ok, apagou os trem que precisava. Join. Não é isso que eu ia fazer não, né? Play, create, ready. Nice.
Make sure to start from the lobby scene, so not from this one. Let's go into the lobby. Okay, let's make a build and test. Okay, so on this one, let's create a game. There you go, created. Then on this one, let's play. Let's join the game. Yep, we have joined. Now on this one, set as ready. And nope, nothing happens just yet. Now on this one, set as ready. And after a little bit, yep, they both load. Okay, great. So far, so good. Now let's go back into the character select scene and let's build a proper visual. So actually for that, let's first go into the main menu scene. And over here, let's copy some objects. So let's pick up the main camera. Let's also pick up the virtual camera, pick up the floor, the global volume, and the directional light. Okay, so let's copy all of these, Control C. Let's go into the character select scene, and let's destroy the main camera and directional lights. So delete these, and press Control V, and there you go, we have our objects. Okay, so with this...
Oxi, eu copiei, mas não copiou não. Cara... Floor, global volume...
we have the basic visual. Let's just zoom in over here. All right. Now let's position the virtual camera. So let's put it on position 0, 1.4, and minus 3.7. With rotation on 2, 0, 0. Okay. Now here, let's create a brand new empty game object. Name this the player 0. Let's reset the transform. And now inside, let's add the player visual. So inside...
peraí.
Inside the assets of prefabs, here is the player visual. Let's drag it on there. And there you go, there's the player. Let's just make prefab. Now here, let's create 3.7.
Ué, por que a minha câmera é diferente dele?
With rotation on 2, 0, 0. Okay. Now here, let's create a brand new empty game object. Name this the player 0. Let's reset the transform. And now inside, let's add the player visual. So inside the assets of prefabs, here is the player visual. Let's drag it on there. And there you go, there's the player. Let's just make them rotate to face the camera. And okay, so we have one player. Now let's just position 4 players. But actually before that, let's make this one a prefab. So let's drag the player 0 in order to make it a prefab. Let's name this the character select player. Now here, let's a prefab. Let's name this the character select player. Now here let's make all our 4 players. So D0, D1, D2, and player 3. Okay, now let's position them. Let's position them not perfectly, so a bit more off, just to make it look a bit more interesting. So player 1, player 2. Alright, so here we have all of our players. Now let's make the script. To run this, so let's create a brand new C# script. Let's name the same thing, so the character select player. And now let's make sure to add the script onto the prefab itself. So let's open up this prefab, and in here let's attach a script. Okay, now let's open it. And over here let's add the usual show and hide functions. Basically we're only going to show as many as we have players connected. So a private void show, and a private void hide, and the usual thing, game object set active into either false or true. Okay, great. Now we need to handle the number of players that are connected, so we know which one of these we should show or hide. And then afterwards we're also going to need to store the player data, like for example the color or the player name. So for that, let's go into the kitchen game multiplayer over here on this script, and the data type that we're going to use is going to be a network list. So this is kind of like a network variable, except obviously it supports a list. And for the type, let's actually make a custom type. This is a great way to learn how to serialize custom types. So first for the type, actually over here, let's make sure to save the prefab, go back outside, okay. And for the type, let's create a brand new C# script and call it the player data.
Ok, pera aí.
Okay, so this is where we're going to store all of the data for the player. So for this one, let's make it instead of a class, let's make it a struct, since we're just going to hold some data, and this one does not extend mono behavior. Now for that over here, right now, let's just begin by storing just the client ID, so a public ulong for the client ID, so just like this. And now back here on the kitchen game multiplayer, on this one, let's go ahead and make a field, so this is going to be a network list of type player data. And we have the player data network list. Okay, there it is. And right away we do see we have an error. In order to use a type inside a network list, it needs to implement iEquatable. So let's do that. So back in our player data, over here we need to implement iEquatable with a T of this type, so player data. Now let's use Visual Studio to help us implement this. So let's implement this interface, and just requires us to implement the equals function. So let's just return this client ID equals the other .client ID. Okay, great. And back in here now we do not see any more errors. Okay, so far so good. Now for initializing this list, for a network variable, usually we would initialize it right here, except you actually can't do it up here. If you do it, you will get an error, and you also cannot initialize it on a network spawn. So in order to initialize a network list, it has to be done over here on the awake. So player data equals a new network list. Okay, so now that we have this list, let's populate it when a player connects. So let's listen to that callback. So over here on the start host, let's go into the network manager, the singleton, and let's listen to the on client connected callback. So let's listen to this and let's rename this so the network manager. Okay, great. So when the player does connect, connect. This parameter here is the client ID. What it does, let's go into the player data network list and let's add a new entry. Let's create a new player data, and inside for the client ID, let's just use this client ID. Okay, great. So now when the player connects, we're going to update this list with new player, and over here on the Great. So now when the player connects, we're going to update this list with new player. And over here on the character select player, in order to show or hide, we need to know when the list changes, meaning when a player either joins or quits. So over here, let's make an event to notify of that. Let's make a public event handler. Let's call it on player data network list changed. So when that list changed, let's fire it off. And for knowing when it changes, we can either manually fire it off over here, or we can also just listen to this. So listen with the onList changed event. So when this happens, we have this, and over here we fire off the local event. So on the player data network list changed, let's invoke this. Okay, great. So now we have this event. And now back in here, we can listen to it. So on the private void start, let's listen to this event. So that's on the kitchen game multiplayer, the instance. Let's listen to this event. Let's rename this as usual. When this event happens, we want to basically show or hide this character select if this one is meant to be shown or hidden. So for that, we really just need an index to know which player this object represents. So up here, let's add a serialized field, private, a simple int, and call it just player index. Then back here in the editor, let's just assign it a simple int and call it just player index. Then back here in the editor, let's just assign it. So this one start off on index 0. This one, let's give it index 1. This one, index 2. And this one, index 3. Okay, great. And over here, let's make a function to update the player. So private void update player. And on this function, basically let's check if this player index is connected. So for that, let's ask the kitchen game multiplayer. So over here on this script, let's make a function to do just that. Let's make a public return a boolean and just call it is player index connected. And we're going to receive an int for the player index. And over here, we basically just need to know if the player data network list, if that one has this index inside of it. So we just return this player index is under the player data network list dot count. If so, then this player index is connected. So back in this script, we just check if the kitchen game manager, the multiplayer, if this one is player connected, and we pass in this player index. So if this one is connected, then let's show, and if not, then let's hide. Okay, great. So then for updating the visual, we just update first of all over here on
Ih, mas que caralho, isso.
Start, and then of course over here when the list changes. Okay, so that's it. Let's test and see if the correct number of players are shown. Again, for testing, as always, let's make sure to test from the lobby scene. Okay, let's see. Okay, so here let's create a game, and nope, right away we do see an error. In order to use a custom data point, just like we saw, we need to implement iNetwork serializable. If not, then we have this error. So over here on the player data, let's make sure to implement that. So implement iEquatable and then iNetwork serializable. So let's implement this one and let's use Visual Studio to help us. Implement. So we just need to implement this function, and actually this is super simple. We just go into the serializer, so that's this parameter over here, and we just call serialize value and just pass in the reference for all the values in our struct. So in this case we only have the client ID, so we pass it in, although importantly this one is a ref parameter. Okay, so that's it, just like this. Here we are serializing the client ID, so we are serializing everything on the player data. So like this it should work, so let's test. Okay, so here let's create a game, and yep, there you go.
Só que vamos supor que se eu sair com essa aqui e entrar de novo. Dá problema, né?
Right away we don't see any errors, and we also see only one player connected. Okay, so that is correct. Now on this one down here, if I head on play and then join, and if there you go, player 2 is now connected. Alright, awesome. So now that we have the visual showing, let's show the ready state. So for that, let's go inside one of these prefabs, and over here let's create a new, let's go into 3D object, and let's create a world text. Let's put the width and height on 0. This is going to check, and let's create a world text. Let's put the width and height.
Ah, não sabia disso aqui não. Aqui. Eu acho.
Let's go into 3D object, and let's
Ah, em 3D.
create a world text. Let's put the width and height on 0. This is going to just say ready. let's pick a much smaller font size, lift it up by a bit, and as usual, let's put it down center, down the middle, wrapping disabled. Okay, there it is, we have our simple ready marker. Now this one is actually reversed, as you can see. That is basically how text works. Usually for text you see it from behind instead of front ahead. But that's super simple to change. Just over here on the scale, let's put just -1 on the X, and there you go, now it faces perfectly. Okay, so let's name this our ready text, and let's go in the character select player. And over here, let's just add a reference, so a serialized field, private. Let's just use a game object, because all we want to do is enable or show it for the ready game object. And back in the editor, let's drag the reference, exit the prefab, and save the changes. Okay, so now we have these ready counters. All we need to know is when, and save the changes. Okay, so now we have these ready counters. All we need to know is when this player is ready. So for that, let's go into the character select ready. This is the one that we made in the previous lecture. This script has the dictionary, and over here the server is handling all the state, so whenever a player sets as ready, it sets that as true. However, the one issue is that over here this dictionary is only synchronized on the server. Note how this isn't a network variable or anything, it's just a regular normal dictionary. Meaning that all of the clients have this variable, but only the server is actually setting the ready state over here. In order to show the ready visual on all the clients, we also need the clients to know who is ready. So this is pretty simple. Let's just make a client RPC to tell the clients. So a private void, let's call it set player ready client RPC. Let's make this a client RPC. And as a parameter, let's receive a ulong for the client ID. Then over here, we really just access the player ready dictionary on this client ID, and we set this one to true. So that's it, very simple. And we just trigger the client RPC up here. So on the server broadcasts the same message to all the clients, so pass in the same standard client ID. Okay. So that's great. So now all the clients know all the clients that are ready. All we need is to fire off an event to know when this changes. So up here, let's make a public, an event handler, call this on ready change. So we have this event, and then over here, after setting it, let's invoke the event. So this event hours.empty. Okay. So now by keeping it, let's invoke the event. So this event hours.empty. Okay. So now back in the character select player script, over here let's listen to that event. So that's on the character select ready. On the instance, let's listen to the on ready changed event. Let's rename this as usual, keep things nice and clean. So the character select ready. And when this happens, let's call our usual update player function. And over here on this function, so we show the player, and then for the ready game object, we're going to set active based on if this player is true or not. So for that, let's make a function to get the ready state. So based on if this player is true or not. So for that, let's make make a function to get the ready state. So back in this script, let's make a simple function down here. So a public bool just is player ready, and we're going to receive a ulong for the client ID, and simply returns the player ready dictionary on this client ID. Okay, that's it, very simple. And over here, we're going to access that function. So the character select ready. Let's test if is player ready. Except over here, an obvious question is we need the ulong for the client ID. So over here, we need to somehow get the client ID based on the player index. So let's go into the kitchen game multiplayer to get that. Over here, let's make a function to get a certain player data. So over here, let's make one. So a public player data. Call it get player data from player index and receive an int for the player index. And we just return the player data network list on this index, so the player index. Okay, so that's it. This way we can get the player data, and then from the player data we can get the client ID. So back in this script, let's get the player data. We go into the kitchen game multiplayer, the instance, let's get the player data from the index. Let's pass in this player index. And then from this one, we can grab the client ID and we can see if this one is ready. And and then from this one, we can grab the client ID and we can see if this one is ready. And we also need to make sure that this one has the key, so contains the key on this client ID. Okay, so here let's create a game, and there you go, there it is. Now on this one, let's play, let's join the game. Okay, we have 2 players. Now on this one, let's set as ready, and yep, there you go, we have a nice ready counter, and yep, it is synchronized. And now on this one, let's ready as well, and yep, there you go, the usual ready logic works, and the game does start playing. Alright, awesome. Okay, so next let's handle the player callers. First, let's actually...
Tá, calma aí. Virei aqui. Dá play aqui. Ah, é, né? Que você deu era ele já começa. Viajei aqui. Como eu imaginei. Ele não atualiza, né? Uhum, uhum.
Start by defining the colors. So let's go over here onto the kitchen game multiplayer and let's make that. So let's make another serialized field. Let's make it a list of type color. Call it the player color list.
Tá, então pera aqui. Volta aqui. Pausa isso aqui.
Now back here in the editor, let's assign the colors, and that object is created on the lobby scene, so let's go there. Here we have the kitchen game multiplayer. And yep, let's add all of the colors. So let's add 10 colors. Let's start off with a simple, nice yellow as usual. And again, importantly over here, make sure to set the alpha on 1 on all the colors. So we have a yellow, then let's have maybe a nice green. After that, maybe a nice orange. Then a nice light blue, something like this. After that, let's go with a nice purple, maybe something like this. Then let's go with a bit more pink. Then maybe perhaps a darker blue. And after that, let's go with some basic ones. So let's go with one in pure white. Let's go one a bit in the middle. And let's go to one almost black. Okay, great. Here are all the colors. Again, make sure you have all of them on alpha set as 1. You can see the little bar down here, the little white bar. If the alpha is on 0, then it's in black, so make sure this one is fully alpha as 1. Okay, so we have defined all the colors. Now let's make a script to handle the player visual and apply a color. So let's create a brand new C# script. Call this the player visual. And now for attaching this, we want to attach it to the visual itself. So let's go back into the character select scene, let's save it. And over here on this one, we do not want to attach it just on this prefab. So let's open up this prefab, then we have the player visual, and let's also go inside the player visual, and now here we add it. So let's add the player visual component. We want to make them like this so that this script is also attached when we go into the game scene. Okay, let's open this script. And on this one, let's begin by adding a field for the body and the head mesh. So a serialized field, private for a mesh render, for the head mesh renderer, another one for the body mesh renderer. Okay, back in the editor, let's drag them. So drag the head and the body. Okay, great. And now, in order to make sure that each player uses a different color, we need to make sure to use a different material for each of them. So over here, let's store a material for our material. And now importantly, let's make a private void awake. And then awake, for this material, let's construct a new material using the current material. So basically we're going to clone it. So let's go into the head mesh render, grab the material, and this is going to clone the exact same material. So we do that, and then we go into the head mesh render, set the material to this material, and same thing for the body. So this way we are making a clone, so it doesn't apply to anything else. If you don't do this, then changing one material won't change the visual on all the players since they would all share the same material. Okay, so now let's make a nice function to set a color. So a public void set player color, and we're going to receive a color. And over here, very simple, just set the material.color into this color. The material is already being used by the body and the head, so just modifying the material color will already change the visual. Now we want to set the color right away, so let's do it on a private void start. So let's call set player color, and to do that, obviously we need to know which color to use. So let's go here onto the kitchen game multiplayer, and let's make a function to get a color. So down here, let's make that simple function. So public, return a color, call it get player color, and we're going to receive an int, and let's call this the color ID. We're going to store the color ID in the player data in a little bit. Over here, we just return, going to the player color list, and let's grab the color ID. Okay, so with this we have a color, and over here we can go into the kitchen game manager, the instance, and get the color, and we need a color ID, and for now let's use the player ID as the color ID. But again, over here we have a problem, we don't have any player ID, so we can either make a function to set the player index and store it over here, or we can just call it from elsewhere. So actually, instead of setting the player color over here, instead of that, let's go over here onto the character select player, and let's add a player visual, player visual. Back in the editor, let's drag the reference, and let's exit out of this prefab, save the changes. And on this one, let's drag the reference to the player visual. And on this one, we do have the player index. So now here we can do that. So when we update the player, we're already grabbing the player data. So let's go into this one, set the color. Let's go into the kitchen game multiplayer. Let's get the color and pass it. Then let's pass in the player index. Okay, that should do it. So now the second player should have a different color. Let's test. And now here if we create, and there you go, that one is using default color. Now on this one, if we join,
Chama.
And if there you go, we have the second color. All right, awesome. So now that the colors are working, let's make a UI to manually select a different color. Over here on the character select scene, let's go inside the canvas and let's create an empty game object.
Tá, pera aí.